Number 13 is always already similar to problems we have done. So which of the following is equivalent to this expression? So let's do the long division. 5x times what is 10x squared? The answer is 2x. Change and change. 5x times what is negative 15x, negative 3. Multiply and multiply. Change, change. And we're left over with a positive 2. So I want 2x minus 3 in front. 2x minus 3, nope, 2x minus 3. So the only 2x minus 3 we have here is in B, plus 2 over 5x plus 1. Correct answer is B as in boy. Number 14 is like number 1. Number 14 is like number 1. Clear your calculator. This says to take the quantity 5x plus 1 and cube it. So I'm going to write it 3 times. And this is just to ensure that I'm not making a mistake with parentheses and exponents. And we could use additional parentheses to make sure we do it right, but I just want to ensure that this is the simplest way for you to do this problem. All right, so we have this. Let's graph it. Okay, now I want to know which one of these is similar. So let's start with 5x plus 1. So I'm going to go to the second one, type in 5x plus 1, then 25x squared, subtract 10x plus 13. I can see they are not the same. Does everybody see how they're not the same? Now let's save time. Does everybody see how I start with a 5x plus 1? Or any other ones 5x plus 1? Let's go on and do B. So B is I have to keep 5x plus 1. I keep the 25, but now I change it to a plus 10x minus 13. There's the first. And there's the second. Is it the same? Yes or no? Not the same? Okay. So let's come back. Now let's change this to 5x plus 5. I can delete the 2 by hitting the DEL at the top. So I have 5x squared minus 10x plus 13. Right now I've just typed in option C. It's graphing them. When this stops, then both have been graphed. It's done. They're the exact same line. Correct answer is C. Which one of the following has zeros of 1, 1 plus I, and 1 minus I? Okay, clear your calculators, please. Second, plus 7, 1, 2. Let's start with the first one. X to the third, subtract x squared, plus 2x plus 1. And graph. Okay, I'm looking for something that has an x-intercept of 1. I can already see this does not have an x-intercept of 1. So cross out option A. Let's just choose another one. Let's do option B. So I already have x to the third done. Now we want subtract, and you can insert, if you want, a 3x squared, or you could press clear and type it in. 3x squared plus 4x minus 2. I graph it. Does this have an x-intercept of 1? Is there any other x-intercepts? Yes or no? No. I believe this is my answer. Now, how can you verify this? Again, I'm trying to teach you just testing tactics to get answers if you have not fully understood concepts yet. You could also graph these. If these only have an x-intercept of 1, then we could look even further. But I'll tell you from creating these problems that only one of these has one x-intercept of positive 1, and it happens to be b. Problem is done. Okay? The remaining answers are complex solutions that do not appear on our graph. Go down to number 16. Okay, we're going to use synthetic division here. Synthetic division. So let's start with this. To use synthetic division, here are the factors I have. I should have had parentheses around these. That means x equals -2, x equals -4, x equals +2, and x equals +4. Let's start with A. So I'm going to put a -2 up front. Then it's -2x to the third, 3x squared, 4x to the first, and the constant. I want to see which one has a remainder of 157. Bring down the first number and multiply, add down. Multiply, add down, multiply, add down. That does not work. A does not work. Let's try C. Put a -4 out front. -2, 3, 4, -3. Bring down the first number. Multiply, add down. Multiply, add down. Multiply to get 160, add down to get 157. So -4 works, which would come from the factor x plus 4.